That is a workshop called Don't Sleep on COTS, presented by James and Max from both 5254 and 6328. They both have a long, illustrious history of, I guess, making robots from different resource levels, as well as, second place finishes, including last night at trivia, which was fantastic. So now we'll hand it off to them, and we'll ask questions at the end. So feel free to ask questions in the Discord or on Twitch, and we'll get to them at the end. So take it away, James and Max.
All right, thanks for that introduction. Can you hear me?
Yes, we can.
Perfect. So hi, everyone. My name's James Temple. I'm a former student way back 2009 to 2012 and a current mentor for Team 5254 Hype. I'm joined by Max Westwater, also a former student from 2014 to 2016, and also a current mentor for Hype as well. He's also a mentor for Team 6328 Mechanical Advantage out of Littleton, Massachusetts. So thanks for joining us for the presentation. This is Don't Sleep on COTS. Of course, we're talking about commercial off-the-shelf COTS parts from vendors like AndyMark, VexPro, Rev, West Coast Products, ThriftyBot, so on and so forth. Sorry to let you down if you were here hoping that this was going to be about actual COTS. So anyway, what you'll hear today. The key message from us, we want to share a few tips and tricks on how to scale your manufacturing capabilities in-house while still leveraging COTS parts where it makes sense to do so. Max and I both have experience mentoring on 5254 where machining resources are pretty limited. We're working essentially with a space about the size of an area of a walk-in closet. And in there is where we have to kind of keep all of our tools and manufacturing. So we've had to rely pretty heavily on a mix of parts or components that we can buy and standardized materials that we can modify easily for our needs with simple hand tools. So we think there are a lot of teams in FRC that probably face the same challenges that we do. So we're going to start our talk with some more details on our own team's resource growth after over the last few years. Then we'll talk about a couple of quick examples of teams that we think are really competitive, leveraging COTS parts on their own robots. And then the importance of incorporating, of course, game analysis and strategic design into your team's build process. We'll also go through some things to consider in the kind of make versus buy argument that we all go through. Talk about some key low-cost components to make our build seasons easier, and then how to begin adding in-shop or in-school manufacturing techniques on a budget, how to properly scope your robot design when you start adding in more capability, and we're going to leave a good chunk of time at the end to go through some discussion, answer questions, and things like that.
So like James mentioned, we're going to get started kind of talking through 5254's progression of resources and how we grew as a team. So the quick history about us, 5254 was founded in 2014, starting out of our school's wood shop. Working with aluminum was new to the shop and new to the school. There was a lot of things that we had to learn throughout there. And then as we progressed in 2016, we acquired a few 3D printers and started getting more into utilizing that as our first kind of big custom manufacturing. And then in the middle of the 2018 season, we got our first CNC machine, which was a big game changer for us to step into actually more custom parts. And then finally in 2020, in our robot, which unfortunately never actually got to hit the field in a real match, we utilized the CNC a lot more, and the robot looked significantly more custom than a lot of our other robots. So here are all of the robots in question. As you can see, 2014 started out, looks like basically a sales pitch for the VexPro system. We heavily relied on the VersaFrame system to build basically a simple low-goal scoring robot. And we had a lot of success that season just kind of by scoping our kind of selves correctly to our resources. In 2016, we were still using the VersaFrame system. Just at this point, we had gotten more experience with it, and kind of started trying some new things and being slightly more ambitious. This is also where we started getting more into 3D printing. At this point, because we were new to it, we were mostly doing kind of non-structural components, things like sensor mounts, and a few other kind of small, not super high load components. We started 3D printing the pulleys for our intake and some other things like that. 2018, we did a lot of the same. Probably the biggest thing to stick out this year was we utilized the Great Elevator, which was kind of our biggest like integrated COTS component. And that allowed us to have a lot of success that year and build something that we probably wouldn't have been able to on our own. And we also started experimenting with some of our own CNC parts. And then our 2020 robot, we started kind of pivoting to a more custom drivetrain. Previously, we had used basically exclusively the Versa chassis. And this year we kind of swapped up gearboxes and actually milled the tubes on our router. And then as you can see, basically all of the superstructure is custom cut polycarbonate, which we also made on the same router.
All right, so next we'll talk through some real world examples of a couple of other teams that we think do a really nice job of kind of mixing both the custom and the COTS. So next slide. Okay. So the first thing I'll say here, if you don't see your team on this list, obviously it's pretty small. It's not an exclusive list. It's not all encompassing, but just a couple of examples that we thought we could go through really quick. I'm sure that many of you have your own teams or others that you know of. So the first one, Team 133 BERT from the state of Maine. This is their 2019 robot that you see up in the right-hand corner there, the green one. So they finished the season with a record of 69 wins, 26 losses, 2 ties in 2019, won 2 district events, and then also their championship division. A lot of hard-fought matches for them there. Using a mostly stock Andy Mark AM14U kitbot drive. I think they added pneumatic wheels, but other than that, it was pretty much stock. And then they had a mostly 1x1 aluminum tube elevator system, and then a wrist and an arm on the end of that for working with the cargo and the hatches. So very simple robot. This is one of my absolute favorites from 2019. I think most teams could have probably built this robot from a mechanical standpoint. Obviously, when you get into programming, autonomous, things like that, not always the same skill level. But mechanically, very simple robot. From my understanding, having looked at it, having watched matches, seen it in person. So really, really like that one for that reason. The next one, Team 4039, makeshift out of Ontario, Canada. So this is their 2018 robot down in the bottom corner. They were finalists at 2 of their events, and mostly 2x1 aluminum tube Versa frame kind of robot with a COTS style roller system on the top for dropping off cubes in the switch that year. And then they had kind of a secondary cube grabber inside their frame to handle cubes on the floor as well. Really simple robot from the looks of it. Probably not too difficult to build, and had a great season, even though there was an entire component of the game with the scale that they kind of were able to avoid and didn't have to play. Another bonus here, or kind of more of a shout out, any team that has used the EveryBot design over the last couple of years, or if you go back far enough, 2013, 2014 timeframe, the Robot in 3 Days or Build Blitz kind of designs, any of those are great examples of uses of COTS parts in pretty smart ways as well. Next slide.
So yeah,
okay.
One thing we kind of want to highlight here is that how like mechanically impressive your robot is and how many shiny custom machine parts you have doesn't really matter if you kind of miss the mark strategically. So by studying up on this and kind of looking at some of the great resources out there, you can offset a lot of any like potential negatives that you may have from not having access to tons of custom machining by being super smart about the resources you do have, and for analyzing the game correctly to kind of build the correct robot. So here are just two examples of great talks. Karthik almost always does his strategic design talk at championships, which is one of the best ones. If you haven't seen that, definitely go back and watch it. And then there's also a lot of other great ones. The one from Citrus Circuits being another awesome example. Oop, didn't mean to play those, my bad.
All right, so now we'll get into our kind of make versus buy discussion, or maybe argument's not the right word, but the discussion that all teams kind of have during their build seasons. So making the decision to make something, make a component or an assembly versus buying it off the shelf. These are just a couple of considerations that Max and I and the other members of our team kind of always have top of mind after we've decided on a game strategy, as Max mentioned in the last slide, and are thinking a little more critically about what it is that we're going to build and how we're going to build it. So the reasons to make something, whether it's a drivetrain or an elevator or an arm or a claw or a shooter, whatever the game is, a couple of things here that we think about. Reason to make. I can make this simple part cheaper and or faster than a vendor could potentially deliver it to me. So we're talking savings of time, savings of money. Another one, the COTS version of my part is out of stock or wouldn't arrive on time. One thing to consider there is, can you substitute it for something different, something equivalent? If not, you may just have to make it. Another one, no vendor sells exactly what it is I think I need. I would caution on that one, that a lot of times people can design themselves into a corner when they're kind of trying to build a solution or solve a problem that a first game presents. Especially today, 2020, going into the 2021 season, there aren't many things that you can't buy. Not saying that you should buy everything, or that every single product is going to be better than what you could make, but it's something you have to ask yourself. Another one, I think I can make this part perform better for my needs than a vendor could. This is an interesting one. I think if you look back maybe 5-10 years, even back to like when I was a student, I think of swerve drives. So back then there weren't a lot of swerve drives on the market, so to speak, that you could go and buy and implement easily. Not that swerve is easy today, but it's probably a lot easier than it was. So for a team today to say that they could make a swerve drive better than one that they could buy, and there's a ton of options on the market now, that team's probably not the target for this presentation. If they could make it better than they could buy it, but it's something to consider. It's something to think about. So on the flip side, reasons to buy. Parts ship fast and frees up your resources for other tasks. So this is an important one, even if it's something, some component that you could build yourself. Let's say it's a drivetrain. If you think that you could use Andy Mark's KitBot, which again comes in your kit for most teams, unless they take the voucher, they opt out. That's a great opportunity to free up some resources and go use that for your superstructure. Go use that for some other part of your robot. So you're not designating resources and tying them up to build something that you could have just gone out and bought to get potentially the same performance. Another one, other teams use that specific part and you could easily find a replacement at an event. So how many times has it happened to you that you've spent all this time in your build season designing and manufacturing this one very specific part, and maybe you don't have a lot of spares, or you don't have any at all. You get to an event, you go out for a match, that one thing breaks, and you go back to your pit and you're thinking, well, how am I going to make this quickly at an event so I'm ready for my next match? And odds are, if you customize that, made it yourself, there aren't any teams that could help you find a replacement, and pit admin probably doesn't have it in spare parts either. Whereas on the flip side, if you did have a COTS component there, especially if it's a popular one. It's more than likely something that someone could find you a replacement for. Next one, I can't make the part myself, or if I tried to, I couldn't afford the wasted time if it failed. This is a big one for hype. So Max mentioned earlier that we have our CNC machine now, but when we first got it and when we were first learning how to use it, we spent a lot of time making parts that didn't really look the way we wanted them to, or didn't turn out the way that we thought they would. If you're in the middle of a build season and you're sitting on your CNC for hours and hours and hours, if you're on a small team like us with not that many students, not that many mentors, that can really waste a lot of your time. And so that's another one where you have to be cautious and really evaluate. Next one, the vendor sells a part for a lower price than I could make it myself. That's maybe not a super common occurrence, but if you do find that you could pick something up cheaper than you can make it, by all means, save the money and save the time. And the last one, this COTS version of the part performs superior to my own. Think about like Teflon coated gears that you can buy from VexPro, or other parts that, you know, maybe the machining tolerances are higher, or you know, any number of other things that could cause the COTS version to just perform in a better way. So take that into consideration. Next slide.
So this is kind of getting into what are kind of some of the best parts that you can end up buying. And one of the things that we kind of want to highlight here is that there's a lot of these parts that are kind of reusable year to year. And there's similar kind of themes for different game pieces. Like it shows here, like every year you need a drivetrain. Most times you need to possess some kind of game piece, whatever that may be. And obviously the intricacies change year to year, but the same kind of concepts carry over. So kind of having this stockpile of parts and kind of common components that you both have on hand, and you also know how they work, you have experience with them, you know kind of like, oh, this wheel is better on this certain type of kind of like this kind of ball or whatever it may be. Having experience with a lot of these kind of same parts makes it so that you can kind of use your learning from the past and apply it to the future more. And also the games themselves kind of fit into a lot of these kind of like overarching themes of like an elevator game versus an arm game versus a shooting game. It's kind of a way that people always kind of think about year to year. But that doesn't necessarily like fit directly. And there are some applications for like say elevators in a game that wouldn't be necessarily an elevator game. It's like say 2018, reaching the scale, you could have used the great elevator like 5254 did. But then come 2020, which isn't necessarily like an elevator game in the common sense, you could use the same or a similar mechanism for your climber at the end of the year. So kind of thinking about there's a lot of these parts which can be applied throughout year to year, and getting kind of used to them and knowing how to utilize them can help you a lot to kind of so that you don't have to go through the struggles of kind of like misusing a part and it breaks in some way, and you can apply that kind of knowledge to the future. Another thing is there are definitely a lot of, as we say, free components that come in the kit of parts, not just the things that come with it, but obviously there's all of the virtual kit vouchers, which are great to utilize. You can normally end up getting some nice parts off of Rev or wherever it may be through that. And then also probably, arguably the most important COTS part, the kit bot itself. That I think is a place where if you're struggling resource-wise, you can make up a lot of time there by simply utilizing this already great drivetrain off the shelf. And you need, for a lot of kind of lower level starting out teams, a pretty compelling reason to not go with that, especially with all of the upgrade paths available now, whether it be the ones that Andy Mark sells, the like custom gearbox add-on that Thrifty Bot added this year, or simply just switching out to brushless motors, whether it be the Falcons or the Neos. There's tons of paths forward if you think the base kit bot isn't enough for you, but you can kind of go from there. The other thing that I think we want to highlight on is, and this applies to more kind of sustaining teams and even teams that have their own kind of custom manufacturing resources. Having a lot of these kind of COTS parts almost like stockpiled from previous years and on hand can help you out significantly. Some of the big things that we found helpful and that I think are important is, especially in the prototyping phase and then also in new student training. So at the start of the season, if you want to try out an idea to see if some specific mechanism can work, it sucks to have to sit around and wait for some part to come get shipped and show up just so you can try it out. If you already have a lot of these kind of parts on hand, it can be super quick to just grab them, throw them together, and try out your ideas. That's one big thing that I noticed going from 5254 to 6328, where 5254 is obviously super heavily COTS team. So we have a lot of these parts on hand, whether it be tons of different wheels, all of the different VEX gussets, a bunch of different versaplanetaries and ratios and other gearboxes. So because we already use this construction method during the prototyping phase, we can quickly throw things together to try out ideas. Where with a team like 6328, who makes things significantly more custom, we're a lot more likely to simply just buy one-offs of parts for things we need. So that makes it harder in subsequent years when you want to just try out new things, because you might not have as much stuff on hand. And next slide. This is kind of talking about what you need to work with these COTS parts. So 5254, as you saw, heavily uses the VersaFrame system, which is basically the 2x1 and 1x1 tubing and gussets, which you can use to produce basically anything you want. With the exclusion of like the teams that do custom sheet metal, even a lot of the big custom manufacturing teams use this tube and gusset construction. So the VersaFrame system is super great to allow that same construction method to lower resource teams. So that is kind of great for allowing you to do that. And then also as you transition into more custom machining, a lot of the same ideas transfer over. So the knowledge that you gained doing these COTS construction methods can easily be applied to more custom work in the future. And another thing, so the COTS components are nice in that you don't necessarily have to use or know CAD to utilize them. So when 5254 was starting out, we were mostly doing the kind of construction method of creating basic sketches with overall dimensions, and then just kind of cutting things to length and throwing stuff together. We didn't really fully CAD our robots, which is super nice that this allows, the system allows you to do that. But it also has the great advantage of you can grow into, as you get more experience in design and more students and mentor resources in that, you can still obviously fully CAD a COTS robot. And it's helpful to be able to be kind of accessible to both of those, so that it isn't like breaking barrier, but it also lets you grow into that more. And then kind of quickly touching on tools. So for a majority of 5254's life, most of our robots were basically built with like the four main things shown down here: a chop saw, which had a metal blade, which we put on it, and then a bandsaw with a metal blade, and then hand drills and drill presses, which using the verse frame system, that basically covers most of your bases for making almost anything that you could want. And then at the bottom, that's shouting out, this is the Spectrum $1,000 first tools list. This is just kind of a great resource of, if you're starting out and you only have $1,000, what is an effective way to kind of spend your budget and get the most bang for your buck to get your kind of shop up and started.
Okay, so next slide is a little bit more in depth on the VersaFrame system. Max and I talked about this on the last slide and throughout the presentation, because it's kind of the bread and butter of what 5254 has done in the past and has kind of gotten us to the point where we are now. Again, it's 1x1 or 2x1 dimensional aluminum box tubing connected with various gussets, and there's two primary thicknesses for the material. On our team, we call them thick and thin. They have actual measurable thicknesses, but that's kind of the shorthand reference that we use. And obviously, one's heavier, one's lighter, and the strengths kind of go with it, to put it in a really simple way. Overall, simple and robust construction method. You can build and rebuild quickly. One of the things that we really like to do on our team when we're prototyping is take old chunks of the 2x1 or 1x1, whatever the length is, and just use the holes that have been piloted into it when you buy it. Add some gussets, throw some screws through it really quickly, and use that to kind of mock up frames for prototyping. And then when we come back later and we're ready to, take out the new material that we've just bought and actually cut it down from the size that it ships at, we'll go back and we'll redo the gussets with rivets so that it's held together more permanently. But the screws are really nice because we can chuck an Allen key in a hand drill, kind of put things together really quickly, take things apart really quickly. And it's almost like a Lego style building block system for us to get framing together to do our prototypes as fast as possible. So when Max said on the prior slide or two slides ago that you can buy this stuff, keep it in your inventory year after year, and use it for prototyping to just get started on your ideation and get started on your prototyping that much faster. That's the real benefit I see for us. And again, you can use this stuff for final robots too. I know you see in the bottom right corner there, this robot's pretty old at this point. But if you were around in 2014, you'll remember the Cheesy Poofs World Championship winning robot. That is essentially a Vex VersaFrame version of that robot. I'm not sure if this was ever built or if they just kind of catted it for fun. Not sure if it would really work, but it's kind of an interesting way to think of, take the idea that you have in your head or take the design inspiration that you have in your head, and you can probably get pretty close with the VersaFrame system at the expense of potentially a little bit of extra weight and a little bit of rigidity in what you're allowed to use in terms of the gusseting, because I don't make totally custom gussets to do whatever angles you need or whatever kind of bends or radius you need in your parts.
So this slide, we just kind of want to quickly highlight kind of the broad amount of different COTS parts out there right now. And this is just kind of an example of a comparison to kind of walk you through like the decision process that 5254 does for any particular part. So basically, maybe with the exception of 2020, everything above the drivetrain, 5254, and I think this is true of most teams too, end up utilizing one of these kind of planetary gearboxes for most mechanisms. Just they're a quick, easy way to power a wide array of different speeds, and they're also, most of them are great for kind of experimenting around. So kind of how 5254 looks at them, the VersaPlanetary, we love them for how variable they are. As you can see, they come in tons of different gear ratio stages. So you can quickly kind of swap out stages, motor inputs, add-ons for encoders, just slightly less relevant now with all of the brushless motors, but still a nice to have. And so they're super variable. So that's great, especially in like the prototyping phase, like we said. If you're trying something out, you can quickly experiment with different gear ratios to see what works the best. In recent years, also, 5254 started using the AM sports a lot more. So these are definitely a lot more limited in that you have to buy a specific ratio, but they're super heavy duty. So for things that are high load that we don't want to break, think like climbers or like big arm joints. This is normally what 5254 falls on, mostly just because we kind of want to set it and forget it, and not worry about us being dumb and utilizing lower strength gearbox than we should. It comes at the expense of some weight, but we can know that we're probably not going to explode it randomly at a poor time. And then also the kind of newer one on the market, which 63228 used a decent amount, is the Rev Ultraplanetary. So this is a super cool, the picture I don't think does it really justice how tiny it is, but this with the induction of the Neo 550 as a super great light option for high speed applications. It was actually designed for FTC, so it'll come with this FTC motor, which you can utilize for whatever you want outside of the FRC space. But it's also super cheap, and it comes with all of the gear stages with it. So basically, I don't know, the takeaway for this slide is basically there's tons of great COTS options out there. So depending on what your application is and what your kind of requirements are, chances are at this point in time, there's something that will be able to suit your needs pretty specifically. So this slide gets into kind of utilizing custom manufacturing when you don't actually have a CNC or some real way to do it. So you might have seen about this process highlighted on Chief Delphi other places, but basically this is a way to make custom parts by you basically CAD your design and then you print out a one-to-one scale drawing with the center holes annotated in it, so it's super easy to find the actual centers of all of the circles. And then you take this and you basically glue it on to whatever material you're using. 5254 normally ends up doing polycarb, but you can also do aluminum or wood, depending on what stage of the process you're making this for. And then we normally just use one of these old school purple glue sticks, which you probably have lying around if you have a 3D printer, to attach the paper to whatever the material is. And the purple glue sticks are nice because it is washable, so you don't have to deal with having like sticky glue on your part. So after you rip it off, you can clean it off pretty easily. And then after you glue that on, the next step normally is to drill all of the holes. To make sure you're accurate, we normally use some kind of center punch on all of the holes. The one that is can be tricky are if you have any bearing holes in your parts. So this link here, the link's there, and then the like name of the product on Amazon is at the bottom of the slides. It's the part that you see pictured in the top right. This is what we use for cutting out bearing holes, because that can be tricky tolerancing wise. So this is the part that we found that works the best. I think there's some discussion on Chief Delphi about other people that did some experiments with this, but I think it's definitely, if you're a team doing this kind of thing, it's a worthy investment to get some kind of bit that can easily drill mostly correctly toleranced bearing holes. And then after you drill all the holes, you just go around and cut out the exterior on bandsaw or jigsaw or whatever you may have. So then going through these photos, just kind of quickly about examples of them. So the left one, this is a prototype of a redesign for our 2018 intake. So we weren't super happy with our initial one. So this is the prototype that we made mid-season, which is based off of the 148 intake that flips around basically 180. So these arms start facing backwards. Like James mentioned before, how we just kind of grab stock out of bins from our old robots. You can see there's a bunch of gross holes in this black bar, but that's just because this was the prototype that we threw together quickly, not wanting to waste good material. By kind of having this stockpiling of parts, you can kind of find old things and decrease your costs that way. So the custom part is actually these gussets right in the back, which basically just serves as a pivot, a mount to the elevator, and then a hard stop to get the correct spacing between the two wheels that we wanted. And then also we utilized the same template one-to-one pattern method to mount the versaplanetary gearbox here and the hole up here. But as you can see, we utilized the Vex clamping gearboxes here because we didn't want to have to drill that hole perfectly. So this Vex part can capture the bearing easily, and then also it can slide to tension the belt that's in there. So that is an example of a mostly COTS mechanism. You can see it's also using the Versa blocks, but for the one piece that we did need to kind of get the spacing perfect, we utilized this method to get that cut out easily. The center, this is a 2016 catapult that we made in the off season for Stronghold. As you can see, it is also almost exclusively Vex. It's basically one piece of the 1x1 tubing with a bunch of the gussets for the structure. But then the one custom piece is basically the cradle for the actual ball. So this is a super simple part, but you're obviously not going to find any COTS version of this. So to kind of get it perfect how we wanted, we CAD'd that design and then did the method of basically tracing out the printed drawing. And then another cool example is, so this is 6328's redesigned hatch intake for 2019. So this was actually made at an event, which is kind of, I think, what makes it interesting. So the initial hatch intake wasn't working super great. So this, we made one of the wheeled hatch intakes inspired by a lot of the teams did that year, using the same construction method. And I think this is just a super cool example to highlight how you can utilize this, because we were like legitimately able to do it at an event. We CAD'd it in the pit, went up to the scouting team and forced them to print off these drawings instead of scouting sheets for a second, much to their bewilderment about what we were doing. Borrowed a few parts that we were missing and used, I think it was Team 195's bandsaw in their pit to cut it out. And as you can see, this is a fairly complicated piece. It requires gear spacing between the two wheels, and then a belt spacing back to, there's a versaplanetary back here. So obviously it wasn't perfect. The gears made noises, which were a little scary. But point being, it worked, and we were able to do it in the pits, basically like scrounging parts together. So it's a super powerful method that you can utilize. So don't think of yourself as too limited if you don't have access to a CNC. There are definitely ways around it where you can still make cool, decently custom parts.
All right, so talk through the framing that we use. We've talked through some of the ways that we power things with versaplanetaries and others, and we talked through how we cut things when they're not pre-made for us. So the next thing is 3D printing. So this is great for low or no load applications, as we would call them. So things like camera mounts, sensor mounts, electronics mounting, certain spacers, if they're not, torqued down to the point where they would get smushed, or other things like that. They are capable of surviving in some higher load situations when designed correctly, but you're getting into some, deeper thought processes there. Even cheap printers are often able to print higher strength materials these days. We're not talking about crazy high strength like metal, but certainly better than the kind of hobbyist printing of 10, 15 years ago. And then it's pretty easy to design, print, and install multiple iterations quickly and cheaply. So if you design something at a team meeting and print it overnight, come back the next day and find out that it doesn't fit exactly the way you want, you at least have a working model and you know exactly where your process went wrong, and you can retool that pretty quickly and try again. In the bottom, just going over the pictures quickly, the left-hand side is a hype block that we'll talk about more in the next slide. But essentially, it just allows us to throw a motor onto a piece of 3D printed material, run a belt reduction down to a shaft, and then transfer motion that way. On the right side, that's Team 78. That's their hatch grabber from 2019. Really simple, 2 3D printed pieces and a pneumatic cylinder to actuate, and that was what they used, sliding on a piece of 1x1 Versa frame to manipulate hatches that year.
So yeah, James mentioned hype blocks. That's our name for them. So basically, this was something that came out of 5254 as kind of an idea to more kind of quickly iterate. It was originally, the idea was for prototypes, but it could be extensible to kind of more finalized applications. And I think this is a cool example of utilizing 3D printing in effective ways to kind of speed up development. So basically the idea with this is it's a way to quickly mount kind of motors and shafts and move them around for various mechanisms so that you can kind of quickly iterate on prototypes. And it's also designed so that the bearing spacing on this is the same as the metal VEX side bearing gusset. So you can, if you wanted to, after experimenting with this, utilize the real like VEX metal version if you're worried about it breaking. And then also this, we started using the method of, for a lot of these higher speed applications, you can get the reduction done in simply a simple kind of one stage belt reduction. So you, a couple places we normally get them from VEX make the pinions for the 775 and 550 class motors that you can just press on. And then that makes a super easy way to kind of experiment with different reductions. And because these slide, you can also tension the belts that way. This in the middle, this is a photo I took of a team that was, I can't remember who it was at this point, but this was at week 0 this year, that kind of utilized the same concept and modified it a bit to their own needs. And it was cool because you're able to kind of mount in the middle of this tubing, and it also is nice because it provides the tensioning effect for belts or whatever you're running between them. And then on the right, this was kind of dumb example of a weird hatch intake, which was a nice way to kind of quickly prove that in theory this does work, but it was probably a bad idea, of simply just kind of screwing this 2 1x1 to this random piece of plywood, and then we're able to utilize these the bearing blocks to quickly clamp there, and then attach a motor to it as well. One of the things that we really like about the system is, as opposed to using like drills or other things, we power them with the real motors that we're going to be using on the mechanism, which I think is a lot more indicative of how it's actually going to perform, and makes it so you don't run into some traps further down the line. And then this one in the bottom left, this is an example of kind of a bigger or a different use of this kind of same clamping idea, of it's basically a bearing block which slides over a 2x1 tubing, which it was like the original idea for it was for like a linear sliding out intake this year, but it could be utilized in a bunch of other ways. So I think just this is a cool way to kind of creatively think about utilizing 3D printing. There's a couple other systems out there too. Shout out to the prototype system from Spectrum, which is kind of designed for a very similar situation, of utilizing 3D printing and they use PVC pipe as the structure to kind of quickly make prototypes and adjustments. So there's a lot of cool things that you can do with the hobbyist grade 3D printers that a lot of teams and schools have access to at this point.
So this is our last slide before we get to questions. And this one is more of kind of a cautionary tale based on what our team's gone through over the last couple of years. So easing into manufacturing resources, higher order than hand drills and chop saws like we talked about earlier. So really talking here about CNCs, that you could purchase and then put on a bench top at your school or in your shop, or designing for using machines that maybe a sponsor might make available to you, lasers and water jets and other CNCs and large machines. Some teams have them in their shops if they're lucky, but again, some use sponsors. So don't feel like you need to stop using COTS parts in your construction and in your build and in your design. Again, even though we leveraged our CNC pretty heavily in 2020, there's still a ton of COTS stuff on that robot. There's a lot of VersaFrame on it still, not as much as in years past, but throughout the drivetrain, of course. And we're still using COTS gearboxes everywhere because we're still scared to make a custom gearbox, especially for a drivetrain. Maybe we would do it on the superstructure, but we really like doing small belt reductions and things that kind of grow out of the height blocks that we talked about on the last slide. We'd recommend pick specific components that will gain you the most advantage from being custom if you're going to go custom. It could be a competitive advantage in that it gives you some on-field ability that you wouldn't have otherwise had, or it can be educational. So you might be a team that says, hey, we're gonna go out and we're going to start doing custom machining specifically because our kids want to learn about it. Our kids or our students are really interested in doing this, really interested in learning more about CAD, design for manufacturing, and all of that. There's nothing wrong with that. And then finally, final solutions can, of course, still be custom, but your existing COTS components that you have from years past, like we did this year, can be great for quick prototypes, experimentation, sometimes as swap-ins or replacement parts like that as well. And that about wraps up our slides.
All right, cool. Thank you, guys. We do actually have a lot of questions from the chat. Oh, you can't see me. One sec. All right. So let's get started. This is a question from Cycron, actually. What are some COTS parts that you like to have on hand for prototyping or the final robot?
Max, you want to start?
Yeah. I think the versaplanetaries are a super great thing because they can power almost any mechanism and a very wide array of gear ratios. So that's great for experimenting. And then I think another one that might be overlooked a bit is having a wide assortment of different wheels for intakes and such. So there's a lot of different options out there now. There's tons of different compliant wheels and different durometers, Coulson, stealth wheels, whatever it may be. So kind of having a good assortment of that, because they all, different ones work better on different games.
The one I would add is, and Max might kill me for saying this, but I love having older motors like window motors, or snowblower motors, or things like that. I know people are probably rolling their eyes at me, but I love these old style motors that have either anti-backdrive built into them, or they're super high reduction already. So you may not get something that's final, like you may not be building a climber with a window motor, but if you needed to lift a lot, or you had a significant force that you needed to overcome or exert, I like having those motors that maybe you don't use very often kind of in a back pocket. If you can think of a way to interface them. Obviously some of them have kind of weird output shafts, but those are on my list.
I'm glad you didn't say throttle motors, but other than that, from Tegan 4476 in Twitch, they ask, what method of cutting do you find is most precise when looking to cut out very accurate pieces? So
we normally end up using the chop saw for basically everything. I think the important thing with this is to have kind of go through the process with the students and have decent discipline with measuring correctly and then using normally a scratch all and a square to get a perfect line. And then also make sure, normally one thing we do is like put an X on the side that you're going to cut so you don't mess up the blade width and be off like by 1/8 of an inch. So yeah, a chop saw with the high quality metal blade and then just being disciplined about measuring and actually setting it up correctly.
I would say band saws as well. We have a tabletop one that's kind of out of shape at this point, but it still works. If you take things really slow, especially if you're cutting softer plastics, like we use it a lot for polycarbonate, I find that you can be super accurate tracing a line with that. You just have to take your time with it, and don't force the material through the blade.
Awesome. All right. A question from Scott. He asks, what parts or functions do you wish were offered as COTS products?
One that I always wanted, which I think West Coast Products might have actually made this year, but I haven't tried it yet, is a COTS like brake of some sort for like elevators or arms or things. We used the Versaplanetary ratchet before, but we did not like it at all and found it very unreliable. So something that can help brake mechanisms to hold them up so you don't have to use like constant force springs or anything for like an elevator, for example.
Yeah, I would agree on the ratchet. I would love some COTS component that would allow me to disengage a ratchet or re-engage a ratchet, whether it's take the VP slice that you have right now, some pneumatic actuator on that would allow you to flip that switch on and off. I've seen teams do something like that custom, but it would be really cool to have that packaged so you could just drop it in line with your motor.
Did Pauline freeze there?
I
think
so.
All right.
I can take over questioning for
go for it,
the last
Zach.
couple. All right. So actually, this is a question for me. But what's your favorite? Like you're talking about, like utilizing all parts of what you get, right, including kit of parts items. What's your favorite thing that you've gotten the kit of parts, and like how do you use that effectively on your robots?
You mind if I go first while you think, Max?
Yeah, go nuts.
So going back years and years, over a decade now, in my experience in FIRST, we get every year these IGUS linear slides and these little plastic parts that kind of go with them. And you get the E-chain, the energy chain in there too. And I know people like to use that as like a whip and hit each other with it and play with it and whatever. But I've used energy chain before, and I think most people know how to use that now. The thing that I love is the linear slides. I think they're coated in magnesium. I may be wrong about that. Someone I'm sure knows the exact answer. But we use those in 2019 for our hatch grabber to actually shift it in and out over the bumper closer to the feeder station. And it was a big win for me as a mentor getting to finally use those. And I think a lot of teams could probably find a use for those at some point. Instead of drawer slides in some situations or things like that.
Max?
So James stole mine. That was what I was about to say. So as my fallback, I'm gonna do the cop out and say the virtual kit as a whole. There's a lot of great things that you get to pick there, and you get to choose what you want. I will say the least favorite is the throttle motor, but I think that is not very
hardest to use.
Yeah.
I mean, 469 was able to use it in 2013, right? I think they use that to adjust their shooter up and down.
Mm-hmm.
But that's the only time I've ever seen it ever. All right. I think that's all the time we have today. Thank you both so much. Thank you, Max and James, for this presentation. I hope it was very useful for people. And we will be hopefully putting out their presentation on the Beach Blitz website, as well as Chief Delphi, and some hopeful contact information if you want to learn more about what they do. So thank you so much, James and Max.
All right, thank you.
Yes, thanks everyone.
So in a couple of minutes, we'll get started with our next workshop, and that is going